Okay, here's our all things circles cram for our OST. So please make sure you have a calculator and some colored pencils. I will color code as I go. I am not going to do all the calculating for you. I'm going to tell you how to do stuff, and you're going to have to get your calculator and get some of the answers. Okay, so the first idea is central angles. So central angles are angles that have the vertex in the center. So this is vertex in the center. Is in the center. Now I know this picture is a little bit wonky, but it's supposed to be in the center. So let's pretend like he's in the center. That means this green angle is a central angle. Also, this orange angle is a central angle. Those are both central angles because the vertex is in the center, if the picture was pretty. That means that the angle and the arc match each other. So that means whatever the measure of this angle is right here, it's the same as the arc out here. And the same thing would go for this green one. Whatever the angle is in here, it's going to match the angle out here. So that's going to be true for all central angles. So you can easily see on this orange one that if it's 130 out here, it's also 130 in here because their central angles are equal. Now we don't have any information on this green guy, but we do know some things about circles. We do know that all the way around a circle is 360 degrees. And we do know that means a half a circle is 180. So we do have a half a circle because this is clearly a diameter. So that means the total from here to here has to be 180 degrees. So we can do a little mathy math. If this part is 130, the green angle has to be whatever 130 plus whatever makes 180. So we can just do 180, take away 130 to get this missing green angle here. And so that's going to be 50 degrees. And whatever's on the inside matches the outside because they're central angles. And this side over here, we can see that this is 180 also. That way we do get 360 if you go all the way around the outside, and it would be 360 all the way around the inside, because this obviously is a straight angle, which is 180 over here. Let's take a look at this picture over here. Now we have the same thing going on. Every single angle in this picture is central because the vertex is in the center. So if we talk about every single angle, this one, this one, this one, this one, and this one, they're all going to be central angles. That means the outside matches the inside. So if this arc out here is 15 degrees, then that means the angle in here is also 15 degrees. If we have this 90 here, that means that it's going to be 90 degrees out here also. Now, just like in this picture, we can use any old facts we have. Now, we do know things about half circles and whole circles, so we could probably figure out some other pieces of this picture. We also have old stuff, like we do have an X in this picture, and that means that we do have some vertical angles, right? Remember, vertical angles are congruent. So if we have this 15 on this side, we also have 15 on this side. So that brings us over to the other side, and this is 15 degrees here. And then we could use some half circles. I see quite a few half circles. I could use this half circle right here in blue. So all of these angles here have to add up to be 180. And all of these angles down here have to add up to be 180. So if you take a look at these angles on this half, we got a 15, we got a 90, so we can figure out this one because it has to add to be 180. And the same thing down here, we have this 15, so we can get this chunk, whatever that number is that adds to be 180. So finish those, do your math with your calculator, and get the rest of those angles. The next kind of angle we'll talk about is the inscribed angles. So inscribed angles are not central angles. In this picture, we do have a central angle. An inscribed angle has the vertex on the circle. Vertex is on the circle, so not in the middle anymore. So in this picture, an example of an inscribed angle would be this one right here. So the blue angle is inscribed because the vertex, the point, the bottom of the V, basically, vertex, is on the circle. Okay, so we don't have, and there's something that's true about that. So the angle and the arc have a relationship, but they're not equal to each other like the central. Instead, the arc out here is twice as big as the angle in there. In other words, the angle is half the size of the arc. So if you think about an ice cream cone, so see my ice cream cone here? It has a pink lid at the part. So we have the ice cream on the top, and we have the bottom of the cone. So this is going to be 2 times as big. So this is 2 times as big. 2 times as big out here. So if we knew either one of these, we can get the other one because we can cut it in half or double it, whatever we have to do. Ice cream is always bigger than the cone. Look at it. Even looks like it is. Okay, but we do know some stuff from the last stuff we just did. You see this angle right here? The vertex is in the center, so this orange one is a central angle, right? Central angles are equal on the inside and the outside, which we just did in the last problems, right? So I have that 146, so that means this pink part out here is also 146 because it's going to match the inside and the outside. Now, if we know this ice cream is 146, we know the cone is half the size. So we can take 146 and divide it by 2 to get that inside angle. 146 divided by 2 is 73. So this angle X right here, X equals 73 degrees. Okay, let's look at this guy under here. Okay, it says we have a triangle XYZ that is inscribed in a circle, where XY is a diameter of the circle, and then we have some measurements of some pieces. So here's what this looks like. It's a circle, obviously. Inscribed means all of the vertices are touching it. So we have a triangle. Now we have XY is the diameter, so that means it's a diameter, so that means it has to go all the way across. So XY is a diameter. And we got to make a triangle XYZ. So that means that Z must be down here somewhere, right? Or up there, it wouldn't matter. So we have a triangle XYZ. Inscribed means all of the vertices are touching the circle on it. Okay, so we have some measurements. So from X to Z is 16, that's this piece. Y to Z is 30. We're talking about the triangle now. And we want to know the diameter. So I'm just going to call him D. We're going to try to find the D. Okay, so here's the deal. We can use the fact that this is an inscribed angle. I'm going to color him pink here. You see the inscribed angle? Boom, boom. It's like an ice cream cone. You see it? So that means the ice cream is twice as big as this angle down here. Okay, so how far, if this is a diameter, how big is this ice cream? So this ice cream is half of a circle, so it's 180 degrees, right? 180 degrees. So half of that is 90. So that makes this angle down here 90 degree right angle. Now that makes things a lot easier because if you have a triangle that's a right triangle, remember, any triangle that's right, we know that we can use the Pythagorean theorem or sine, cosine, tangent. We can use trig, right, to help us get something. So we're looking for this side of a triangle. So really, we have a right triangle where we have a 16 and a 30, and we don't have the diameter. So that would mean we can use Pythagorean theorem, a squared plus b squared equals c squared, where remember that C has to be the hypotenuse, the side opposite the right angle, so that means our D is the side that's missing. So we can do 16 squared plus 30 squared is equal to D squared. And we can solve this. So remember, this is the part you're going to do yourself. So get 16 squared and 30 squared, and then add them together. And remember, to get the final answer at the end, you will need to square root both sides in order to get D by itself. And that will give you the length of the diameter. Okay, check out the inscribed quadrilaterals. So inscribed, obviously, we know each vertex has to be on the circle, and quadrilateral is four-sided. So look, 1, 2, 3, 4. Now this was a super easy one to get right on the OST. So all 4 of the vertices are on the circle. Now there's something that's true about this. The opposite angles are supplementary. So they are supplementary, which means they add to 180 degrees. So that means opposite angles. So if I'm looking at this angle, the guy opposite him is this one here. I'll just call him X. So these 2 angles have to add to be 180 degrees. So if I know the 72, right, I could just do 180 minus 72 and get this angle X over here. So go ahead and do that math, and that's going to give you whatever X is. Now the same thing is going to be true for the other opposite angles. So this 110 is opposite of who? This one right down here. We can call him Y. So 110 plus Y also has to add up to be 180 degrees. So can you figure out what Y has to be in order to make it be 180 degrees? So these ones are super easy. If you just remember the ones opposite each other have to add up to be 180 degrees. Okay, so the next one is arc length. Arc length is circumference. Arc length, you're going to use circumference, but since this is just not all the way around the circle, remember we have to multiply it by what part of the circle it is. So it's going to be the angle measure over 360. So if I look up my formula for circumference on my, remember in the back of your notebook you have the OST reference guide, and that is C equals 2 pi r. So that formula is given to you on the OST reference sheet, so you don't have to memorize it, but you do need to know arc length is circumference. So you're wanting to know how long this is. And remember, circumference is the length all the way around a circle. Okay, so we're going to put this in here, except for we have to multiply this by the angle measure over 360. It's always over 360 because it's the part of the circle you want out of 360 degrees, which is the whole circle. So I'm going to do C equals 2. Now I know what pi is. I'm going to use my pi button on my calculator. R is the radius. Remember, a radius goes from the center of the circle to the outside of the circle. So this right here is my R, is 19 times, and I want to know how much of the circle I'm using. So it looks like I'm using 150 degrees of it. So that's 150 degrees out of 360. So I recommend you just put all the numbers in your calculator first. So in your calculator, let's put the 2, do this with me, 2 times the 19 times. Remember, you got to do 150, use the ABC button, 360 equals. So I've got 15 and 5 6. So far I've got 15 and 5 6. Okay, if I want to change that to improper, I could hit the second ABC button, second ABC equals, and it's going to give me 95 over 6. And then don't forget to put the pi on the end of it, pi. So sometimes they leave the answer just like that. So in other words, they multiply all the numbers together and leave the pi sitting on the outside. Or sometimes they change it to a decimal by actually going ahead and putting all the numbers in. So if I were to put all of the numbers in and times this baby by pi, I'm going to get approximately 49.74. So you might see the answer as an exact like this, or you might see it as a decimal estimation. to stop this video and start the next one when you're ready.